So the Atwood machine, we said, was a pulley. We said the second mass is called a counterweight. I think I told you all elevators have this, so that way the electric motor of the elevator is only lifting the passengers. It's not lifting the mass of the car itself. We did a little thought experiment. We said if the masses were identical, they'll stay at rest. That's really handy because that means when the elevator stops, for example, at the 10th floor and everyone gets out, if the elevator just stays there, you're not using any electricity, you're not using any energy, the motor isn't having to do any work. It'll just stay there quite nicely. That's why you have the counterweight system. If we didn't have that, the motor would constantly have to be exerting some kind of a force to keep that elevator up. Oh, speaking of elevators, did anybody want me to go over 7B and or 12D? Any questions from the homework last day? Yeah? Okay. Am I going to put this online? I think I will. So, from many body problems, I can delete that, I think. Anybody get 7B in a way that they think they did it right without just magically trying to crunch numbers on their calculator, desperately hoping they would get a 0.36? Okay. So, first of all, any questions besides number 7 and besides number 12? Any that you would like me to go over? This is your chance to ask. I'm closed today during Flex. I also did email you out an update yesterday. I'll send it out again Thursday after school because, long weekend coming up and get your homework done and all that. Can a 7B, 12D, or both? You got 7B? Okay, I'll talk about 7B because I see some people looking, I don't know how to do that. Well, there's no A and B, but the second part, we'll call it part B, the coefficient of friction. Ready, Gio? Because I'm picking on you. It wants us to find the coefficient of friction, the mu, of the 2 kilogram mass of this one here. You know what? Since I'm not sure what to do, you know what this is a job for? I think a good free body diagram. Okay? So I'm going to draw a free body diagram only on the 2 kilogram mass right there. What are the forces acting on that 2 kilogram mass, folks? Get the obvious one. Yep. And is it sinking into the ground? Is it flying into the air? I think there's a normal force. And then I said, which way is this thing accelerating? Which way is it accelerating looking at this picture here? Yes. So, Gio, I'm going to ask you a different question, but I want the same answer. Which way must there be an unbalanced force? So I did that. The real question is, Josh, what force is that? I thought about it and I thought about it. Any thoughts on what force is pulling the 2 kilogram mass to the right? It's not tension, because tension isn't touching the 2. Tension is touching the 12. Friction. Let me think. If I'm wondering if something is friction, my strategy is I replace it with ice. Let's suppose this 12 kilogram mass was made out of ice. It was a block of ice. And I gave it a yank. Wouldn't it actually slide right out and the 2 kilogram mass would just drop right down? You've done that sometimes before with like stacks of magazines or something. If you give it a quick yank, everything else just drops right down. I think you're right. I think friction. That's the free body diagram on the 2 kilogram mass. Who's winning? Who's losing? It's a trick question. Friction is mu times the normal force equals ma. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. That right there. Which A? I think the acceleration that you figured out earlier, and now you can get the mu by itself. I'll let you take it the rest of the way on your own, but okay. And then I would pause and I would say, I don't think I did anything new there. I just did a clever free body diagram, but there was nothing, no new physics there. Ready for number 12? Also cool. So you got A and B and C. I'm going to do A, the free body diagram, on the box right here. What are the forces acting on the box? Get the obvious one. I agree. Which way is the box accelerating? Well, which way is the elevator accelerating? Is the box inside the elevator? So which way is the box accelerating? So there is a force up. It says scale, but that's a code word. Whenever they're talking about a scale, which force are we really talking about? What does a scale measure? So I said there's a normal force up, but it's got to be less than mg. B says draw a free body diagram for the forces on the elevator. Okay, get the obvious one. In my high-tech system, since the elevator is bigger than the box, I went like this. I used a capital M for the elevator and a lowercase m for the box. See how clever that is? See? Isn't that clever? Isn't that clever? What else? What's friction? Which way up? And it says it's still accelerating down. So, by the way, you'd be screaming, were you inside said elevator? But thankfully, it's only a box. What does C want me to find? Of the? Can't find it. But you know what you can find? The acceleration of the box, which is inside the elevator and accelerating at the same rate. Okay? So for me to do part C, I went, okay. Who's winning? Little mg. Who's losing? Normal force. And that's going to equal little ma. You wanted me to get the a by itself, the acceleration. Kiana, how to get the a by itself? You don't say. This is becoming somewhat, once you have the equation, you're noticing we're either dividing by m to get the a by itself, or we're plussing or minusing stuff over to, it's pretty routine now, I hope. Yeah. So you're telling me, I'm just going to save room, do that. So I'm going to get a equals little m, 32, g, minus the normal force, scale reading, 210, and they gave it to me in newtons, so I don't need to do any conversion. If they had given me the scale reading in kilograms, times by 9.8, now it's newtons, divided by 32. That's going to give me the answer to part C. I think it's going to give me the answer to part C. Bracket 32 times 9.8 minus 210 divided by 32, and there's my 3.2375. You said you got that okay, yeah? Okay. What does part D want me to find? On the elevator? Oh, see the elevator? See my free body diagram? Who's winning? Who's losing? What does winner minus loser always equal? This time it'll be big MA, because apparently that's what's accelerating. How would I get friction by itself? We've done this dance before, have we not? Yes? Plus that over, minus that over, because of the minus sign. I think I'm going to get friction is going to end up being big MG minus big MA. What's big M? I think they told me 725, and they were very careful. They said plus contents, because I do have to include the box inside there now. So thank you, they told me that. So it's going to be 725 times 9.8 minus 725 times A. That's my answer from part C, because the box and the elevator are accelerating at the same rate. I think that's the answer. Is that what I said? 4.76 times 10 to the third? Yeah, because that would round up. Yeah. Quick like money. Is that okay? And then I would pause and I would say, actually, I don't think I did anything new there. That's technically physics 11. The jump is you're having to move from object to object to object to object, and that's the clever part where you have to realize the key is, well, if the box is in the elevator, they're accelerating at the same rate. Is that all right? In fact, that's also the key for the Atwood machine. Wasn't that a nice segue? Let's go back and look at the Atwood machine. We'll work on lesson 6. Lesson 5 is technically due today, but I'll take questions still tomorrow during Flex. I'm just closed today during Flex. We paused here. We got to example 2. I like example 2. There's going to be an Atwood machine on your test. I'm telling you right now. Okay? So example 2 says this. In the diagram below, M1 equals 6.2. You know what, Pierce, why don't I cleverly just label that 6.2 kilograms? And M2 equals 2.8 equals 2.8 kilograms. All right. And then it gives me three things. Connor, it says write force equations, solve for the acceleration, find the tension in the cord. You know, before I do any of that, you know what this is a job for? Yeah. Although technically a free body diagram would be, don't write this down, representing the masses as dosed elsewhere. I'm going to label the forces, because if a physics prof heard you say writing them on here and calling that a free body diagram, they'd say that's technically not a free body diagram. Let's label the forces though. Okay. What are the forces acting on M2? Get the obvious one. So M2G. Is it sitting on a surface? So is there a normal force? What else? Mr. Dewick, I'm feeling some tension. Wait for it. That's it. M1, what are the forces acting on it? M1G and tension. Now, the only part of the physics that you're going to have to figure out on your own is which way this system is accelerating. Which is the heavier mass? Which way is accelerating? M1. Is that okay? It's going to be going that way. I'm not going to draw that in, but you okay with that? Heavier masses will win. So what we're really saying is, on the right-hand side, anything that ends up pointing down is going to be winner plus. Anything that ends up pointing up, once it gets to the right-hand side, is going to be loser minus. Part A says, write a force equation. Who's winning? Okay, ready, Alec? Here we go. M1G, and then Alec, I'm going to walk along the rope. Let me erase that, though, so I don't clutter my diagram up. Tension, winner or loser? Loser. Sort of like the Canucks. Oh, that slipped out, sorry. My bad. This tension, now you might be tempted to say it's a winner because it's pointing up like this guy, but if you follow it, if you go around, and you get to this side, I think it ends up pointing down. Yes? Which makes it a winner plus. Same with this M2G. Again, Ange, you might be tempted to say loser. Sorry, you might be tempted to say winner because it's pointing down. But I think if you follow it, it ends up pointing up, making it a loser minus. What does winner minus loser always equal? Some variation of MA. Here, Alec, do I have forces from more than one mass on the left-hand side? Say yes. Then I better have more than one mass on the right-hand side. You guys got a long weekend coming up? Lose some tension. It's a nice way to get into the weekend. Part A said write the equation. That's it. Okay. Nate, what's part B want me to do? Oh, how would I get the A by itself? What's the bracket doing to the A? Adding, subtracting, multiplying, or dividing? How do I move the bracket over? Remember, I said earlier, Kiana, there's going to be kind of, now that we're looking at all these different situations, the equations may be different, but the approaches, once you're trying to solve, are going to be kind of repetitive. Get the A by itself, we're going to divide. The M1G drops down like a domino. The minus M2G drops down like a domino. It's going to be divided by M1 plus M2. Nate, instead of writing equals A, do you mind if I put A equals on the left-hand side? Because that's where I prefer to see it. Keep going, Nate. M1. Thank you for reading carefully. By the way, it would be very foolish if you did that. However, there is a built-in error check. First of all, I already know A is not going to be bigger than 9.8 because if I cut the rope, it would fall at 9.8 and it's being slowed down. Also, if you're ever doing a question and you get a negative acceleration on your calculator, you picked the wrong winner. That's what it's telling you. Go back, start over. The winning direction is the opposite direction. So that's also a bit of a nice built-in error check. What did you say, 6.2? How big is G? Minus 2.8 times 9.8 all over 6.2 plus 2.8. More built-in error checks. Ready? Who remembers from last day, if these two masses were identical, what was the acceleration? Nothing. The further apart your masses are, the bigger your acceleration will be. In other words, if my masses were 6.2 and 6.1, I'm expecting an answer really close to nothing, because 6.2 and 6.2 would give me nothing. These are reasonably far apart. I'm going to guess we're going to get an answer in like the 4, 5, or 6 range, maybe higher. If I get an answer of 1, I'm going to be a little nervous. You don't have, by the way, you can survive fine, Eric, without those built-in error checks, but I always like to have a gut instinct of what my answer is supposed to be. Anybody crunch it yet? What'd you get? So this type of an equation is one you absolutely have to be able to type into your calculator, because this one will show up quite often, where you have 2 pairs on the top and then a pair on the bottom. 6.2 times 9.8 minus 2.8 times 9.8 divided by 6.2 plus 2.8. You get 3.70 and then a bunch of 2's repeating. A little lower than I expected, but still, I'm okay with that. I'm going to write 3.70 meters per second squared, but you know I'm going to save this on my calculator. Max, what does part C want me to find? Okay. It does not matter which mass you pick, you'll get the same tension, you'll get the same answer. However, can I give you some advice? Think carefully, pick the mass in which tension is a winner. And I'll show you why that's nicer in just a second. Look, which mass is tension winning with? M2. Yeah. So what's my equation for mass 2? Who's winning? Tension. Who's losing? What does winner minus loser always equal? Some version of M8. Which mass are we looking at now? M2, so it's going to be? Yeah. Do you see why I picked tension to be the winner? Because it's really easy to get tension by itself now. You just plus it over. If you had tension being a loser, you could. You would have M1G minus tension equals M1A, and you do the swap. We've done this dance before. Really, it's one extra line, so the time savings isn't significant, but I'm lazy enough that I'm willing to still invest my brain in that. So you're telling me tension is going to be M2A plus M2G, yes? M2, 2.8. A, 3.7, but I'm going to use my answer button, plus 2.8 times 9.8. 2.8 times answer button plus 2.8 times 9.8. You get 37.8. Max 37.8 what? Yep. Once you've written that down, put your pencils down, look up. Yeah. Sorry, what was that? Can't remember. I actually give this in Physics 12, but in Physics 12, I give them the acceleration, and I don't give them one of the masses, and they have to go and get one of the m's by itself. That's a Physics 12 question, going backwards. I'd probably make this worth 3 marks or something. Well, you know what? Probably I'd give you 2 marks for finding the acceleration, and then as a part B, 2 marks for finding the tension. And you know what? I might even have, for here, draw a free body diagram for mass 1 in a separate space, just to show me, I don't know. By the way, speaking of mass 1, very quickly, if you went M1G, don't write this down, minus tension equals M1A, then you did the swapity-do, you'd get tension equals M1G minus M1A. If I actually type that, 6.2 times 9.8 minus 6.2 times 3.70222222, and you'll notice you get exactly the same answer. That's why Max says it doesn't matter which one you pick. Typically one will be slightly easier, but whatever. I have some kids that just always like to pick the same mass because they like the system of it all, the routine of it all. Turn the page. It says find the acceleration of these systems. Let's do the first one first. All it wants me to find is the acceleration. Doesn't even want me to find tension. Okay. Well, you know what this is a job for? Sure, what are the forces acting on the 3.5? Get the obvious one. I'll call it now M1G, because that's my first mass. Tension, yes. Then I'm going to have M2G and tension. Which mass is bigger? Which force is winning? M2G. So anything that ends up pointing down on the right-hand side is going to be winner plus. Anything that ends up pointing left on the right-hand side is going to be loser minus. M2G. What next? Minus tension. Plus tension. Minus M1G. And it's going to be M1 plus M2 times A. Whoop, that's wrong. Put the bracket in the wrong place. Nice. Kiana even yawns on cue. Relaxing. Nice touch. All they want to find is A. How would I get the A by itself? So the M2G is going to drop down like a domino. The minus M1G is going to drop down like a domino. M1 plus M2, A equals. M2, 5.7 times 9.8 minus, that is M1, 3.5. Divided by 5.7 plus 3.5. Yeah? You get 2.343, that there? I'll go 2.34. Is that okay? Yeah. Now, I skipped a bit of a step here, Alec. I didn't actually show what numbers I plugged in. On a test, always show what numbers you plugged in, but in your homework, Ira, if you're feeling lucky, if you're feeling frisky and you want to go to your calculator, sure. If you get it right, good. I don't know what to do, Mr. Dewitt. There's letters, not numbers. Suggestions. What? 1? Let M be 1? Okay, if I do that, what would 3M be? 3. You could also have let M be 2. If you did that, Ange, what would 3M be? 6. You could also have let M be pi. Could have. What would 3M be? Whatever 3 times pi is. Doesn't matter. The only thing I might say if they give me an algebraic question, I tend to stay away from the number 1, even though it's nice to work with, because I'm worried, well, what's 1 times 1? What's 1 times 2? What's 1 times 3? Because the 1 times table behaves like that, I might think something canceled when actually it didn't. But that's more of a physics 12 nitpicky thing. I teach them that one. Avoid 1. 2 is a nice number. Actually, really nice number. 12, because so many numbers go into 12. That's one of my fallbacks as well, because that way I can still do the math in my head quite often. All right. What are the forces acting on 3M? Get the obvious one. M1G. Tension. M2G. Tension. Who's winning? M1G. Now what will I write? If that's the winner, what's pointing up on the left-hand side? If down on the left-hand side is winner, what's up on the left-hand side? Loser. So plus T, you said? I disagree. I think, However, this tension, when you follow it, and it gets to this side, I think it's a plus T. And this M2G, when you follow it, ends up being a loser minus. What's that going to equal? And hopefully they're starting to look a little, not repetitive, but familiar, because I'm giving you a method that works for pretty much anything. Everybody can mentally stretch. Kiana can yawn again. They want A. Oh! Nate, how would I get the A by itself? Okay. So if I hear you, you're telling me A is going to be M1G minus M2G all over M1 plus M2. You might be tempted to try and memorize these different variations. I advise not, also because I can change the question dramatically by adding one more mass or adding something different. But this approach is perfectly valid. Let's try again, seeing if we can do this without sticking in the numbers. Here we go. M1, 3 times 9.8 minus 1 times 9.8. I probably didn't need to type the 1 times, but I'll put it there just so you know what we did. Divided by, can I be lazy and go 3 plus 1 is? I say that a lot when I golf. 4.9. Matt got that joke? 4.9 what? Meters per second squared. Okay. So there's going to be an Atwood machine like this on your test. I'd like you to try number 4 totally on your own. I'm going to freeze the screen. Let's see if we all get the same answer. So it wants us to find the acceleration, let's call that part A, and the chord tension, let's call that part B. Okay? So the screen's going to get frozen. If you get stuck, glance at a neighbor for help. Quick look at Bunny. First thing I would do is label M1 and M2. So apparently M1 is 12.5. And M2 is 24.6. Who's winning? Oh, okay. No typos, Mr. Duke. If you're wanting a check, that's what I got for acceleration. Is that right?
Yeah.
3.196 or something like that. Tension. Hmm. Is that right? That seems high to me. Am I right? No? Yeah? Okay. And if you did it as fast as me, you're in really good shape, because I can do these in my sleep. But you're probably still at the stage where you have to think, and that's good too. Yeah. You want some help? Is that what you're saying? Okay. Oh, washroom. Yeah, hustle back. We'll pause the video for a second. Turn the page. Sneak in a little physics 12. Tato, is this an Atwood machine in example 5?
Yeah.
Yeah. What are they asking me to find? Oh. They want me to find M2. Huh. This is different. Well, let's start out by what? Free body diagram, I guess. What are the forces acting on M1? Get the obvious one. What else? Yo. What are the forces acting on mass 2? Get the obvious one. And? Tension. Do I know mass 2? So I'm not going to start out by going winner minus loser equals the mass of all of them times 8. I don't know mass 2. Which mass do I know? Let's write an equation for that guy. It says M1 is accelerating which way? So if it's accelerating upwards, who's winning? We're writing an equation only for mass 1. Tension minus M1G equals M1A. Now, why did I do that? Here's my strategy. I noticed they gave me tension, Tato. I think what I can do is I can use tension and mass 1 to find A for mass 1, which is also going to be A for mass 2, and maybe if I cleverly then write an equation for mass 2, I can maybe figure out what mass 2 has to be. That'd be kind of cool. So let's get the A by itself. Tato, how would I get the A by itself? So I'm going to get tension dropping down minus M1G all divided by M1 equals A. This is why I said I can't predict every equation you're going to get, but I can give you a method that'll get anything you need to isolated by itself. Tato, according to this question, how big was tension? Minus M1, 3.2 times 9.8 divided by 3.2. Okay, what are both of these masses accelerating at? M1 on the way up and M2 on the way down. Did you get 7.85625? I'm going to write 7.86, but I'm going to store this on my calculator. Now, I'm not done. That's not what they asked me, but I said I can find that. Tato, what did you say they asked me?
Mass of M2.
Well, let's write an equation for M2. Which way is M2 accelerating, up or down?
Yeah.
Who's winning? M2G. And then what?
Tension.
Minus tension
Yeah.
equals which M?
M2.
Okay. What did you say they wanted me to find, Tato?
M2.
How many M2s do I have in this equation? 2. How many would I prefer to have in this equation? 1. You know what? Let's get the M2s to the same side. I don't know what to do, but I'll do that. So if it's okay, I'm going to plus this to here and minus that to there. I'm going to get M2G minus M2A equals tension. How many M2s do I have? 2. How many would I prefer? 1. You know what would be really cool? It would be really cool if it was a grade 9, a math 9 mathematical operation that I could pull out of my back pocket and change this from 2 M2s into 1 M2. And there is. I'm going to pause here. I went shopping yesterday. I have sour Jelly Bellies in my candy jar. If anybody can figure out the mathematical operation that I'm talking about that'll let me turn 2 M2s into 1 M2, there's a candy. Yeah.
M2 squared.
Nope. Good guess, though. Yep.
Divide it and then cancel it.
Nope.
Make it into like, have M2 have coefficient 2 that divide it by 2.
Nope. Ready? Is there an M2 in everything on the left-hand side? Doesn't that mean it's a common factor? So I can factor it. What's that going to look like? It's going to look like this. If I factor out an M2, I'll have a G minus A in brackets. Because if you multiply that out, you'll get M2G minus M2A. That equals tension. How many M2s do I have now?
1.
I like that. How would I get the M2 by itself? How do I move that bracket over, Nate? Ah, wow. Are we coming full circle or what? So you're telling me that M2 is going to be the tension divided by G minus A? It's going to be, what was the tension? Okay, you know what I need to do? I can do this. You guys can't. Haha. Need more room. And then I'll just change this arrow pointing to there. There we go. And let's even cleverly go like this. Nope. Hey, that's nice. What was the tension?
56.5.
Divided by 9.8, take away 7.86, but I'll use my calculator answer button there. Is there more than one thing on the top? No need for brackets. Is there more than one thing on the bottom? In fact, it was in brackets originally, right? 56.5 divided by 9.8 minus answer button. And I get 29.1 kilograms? That's a Physics 12 question. Okay? I've talked a while. I'd love to do, example 6 is the same as example 5, but I'm going to give you time to work on the homework. So, number 1, number 2, 3, 4, I haven't done one. 4 is asking you to find both masses. I gave you the tension and the acceleration, so if you write an equation for each one, you should be able to get the m's by themselves. You might need to pull out that trick of, how many m's do I have? 2. How many would I prefer? 1. Get them to the same side, and if you factor out a GCF, you now have 1 m. You can try that one. 5, 7. That's a lot of work. 9. We'll pause there. How many did I give you? 1, 2, 3, 4, 5, 6, 7 questions, and you got 15 minutes. Okay, I'll live with that.